Hello, Assalamualaikum Saif. How are you?
Waalaikumsalam, sir. Alhamdulillah. How are you, sir?
I'm good. I'm good. Okay. Just one thing. In this class, we'll be majorly doing the properties of D block elements, not F block elements. Okay. So we can write the chapter's name as D and F block elements, but we'll be majorly doing the D block elements. Okay. And here's also here. Okay. So first of all, what is transition elements? Transition elements are those metals which have incomplete D subshells. Okay. This is also known as transition elements. The first thing that you will, the first question that you can get is what are transition metals or what are transition elements? Please don't write, okay? Just listen. Transition metals. I mean, if you want, you can write, but I will not be stopping for anyone. Okay. If you want, you can write. Okay.
So for electrochemistry, how many pages should we leave?
For electrochemistry. But you D and F block for this, now you just write in this in rough copy and then you can figure it out later on. Okay. Write in some middle pages there. Okay, sir.
Okay, sir.
This is for everyone. Those who want to write, they can write, but I will not be waiting for anyone. See, transition metals. What are transition metals? They will have incomplete D subshells in their neutral form or in common.
Good morning, sir.
Good morning. Oxidation states. That is in their common oxidation state. That is in ionic form. Okay. Now, important point. If you look at the last, elements of the EH series, such as zinc, cadmium, and mercury, Zn, Cd, and Hg are not transition metals. Why? As they have complete D subshells. Okay. As they have complete D subshells in neutral and common oxidation states. This is the first thing that you will see. Next thing that you are going to see is like the question that you can get is about the electronic configuration. Okay. What the electronic configuration? An electronic configuration, majorly they will ask you about the ions. So please see.
Sir, can you scroll up?
No, you don't have to write, okay? Just try to listen whatever you can.
Okay.
If you are writing, you can write, but I will not be waiting, okay? I will share the notes, but okay? I'll share the notes. So they will ask you about the ions, okay? So whenever you have P positive, 1 positive, 2 positive, 2 positive, whatever the positive charge is there, that means number of electrons you are going to remove. But you are going to remove from which subshell, that is important. For example, take the case of Cr. What is the atomic number of Cr? Tell me. Chromium. Okay. See, for 3D series, you can remember it very easily. 3D series is Sakti, Vikraman, Feko, Nikuzen. Okay. Feko, Nikuzen. Okay. So this starts at 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Okay, Sakti Vikraman Fekonicosin. Repeat it 10 times, you will remember this thing. Okay, Sakti Vikraman Fekonicosin. So chromium is what? It is 24. So if it is 24, it will be what? 1s2, 2s2, 2p6, then 3s2, 3p6, 4s2, it will be 4s1, 3d5 because it is Cr. Now what we have taken Cr3 positive. Please listen, all of you. Please listen. ठीक है, लिखने पे मत फोकस कीजिए. अगर लिख पा रहे हैं कहीं पे तो ठीक है, लेकिन जब हम बोल रहे हैं तब प्लीज कोशिश कीजिए कि आप नहीं लिखें. ठीक है. Here you have to give. Here you have to remove how many electrons? 3 electrons. So 1 electron will be removed from the 4s, and the other 2 electrons will be removed from the 3d. You'll get 1s2, 2s2, 2p6, 3s2, 3p6, 4s0 will be there, and 3d. How much? Tell me. If you remove 2 electrons from here, 3d, 3.
4,
3 na?
3.
You are removing 2 electrons from the d
Here
subshell.
3 plus.
Cr3 plus.
Okay.
Yeah, 1 electron. First electron will be removed from the 4s. Okay. Let's write a note. Electrons are removed from ns subshell and then n-1 d subshell. Why? Because 4s is the outermost electron, right? 4s, fourth shell main. 3d, even though it is higher in energy, it is closer to the nucleus. It is not the outermost electron. Okay, it is not the outermost electron. So similarly, if you see for copper here, copper +1. So copper, first of all, you have to know what is the normal electronic configuration for copper. Now copper and chromium, you have to remember this. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, right? 4s1, 3d10. All of you know this. Copper and chromium are having anomalous electronic configuration because of the stability of the half-filled 3d in chromium, fully filled 3d in copper. Now for copper +1, tell me guys, where should I remove the electron from? 4s or 3d? Where should the electrons be removed from?
4s.
4s. So 4s1 will become 4s0. Everything else will be same. 2s2, 2p6, ps2, 3p6, 4s0, and 3d will be as it is 10. Done everyone? Yes or no? Please tell me. Okay, I hope all of you understood this. Now see how to remember the 3 series. You have 3D series. आपको मैं बता दिया 3D series कैसे याद करेंगे. Then you have the 4D series, and then you have the 5D series. Okay. Now, you all first of all write this whole thing. Whenever you are trying to remember any mnemonic and all, na, you try it as a whole. So exam ऐसा नहीं कि exam में जाइए फिर उसके बाद try कीजिए. For 3D you are going to write Sakti, Vikra, Man, Feko, Niku, Zan. Then now for this particular group, you're going to write second year लाएंगे AC. Okay. Now forget about AC. That is going to be actinium, lanthanum, yttrium, and scandium. Now from Ti you will have T zara half. From here it is wo nawab tha. Okay. This is chromoton. This is very important. It is man tak re. And for Fe it is just like ferrous, RuOS. This is for कौन रहेगा Ireland. नहीं पढ़ पाता. This is क्यों आगे आओ. And for ZnCdHg, you should remember this as it is ZnCdHg. Okay. Important thing about these elements, we will discuss this, but you can write it here. This has the most number of unpaired electrons. As you can see, chromium में अगर आप देखिएगा, chromium, this 4s1 is also unpaired, the 3d5 is also unpaired. So in total, they all of them are going to have 6 unpaired electrons. Okay, they have the maximum unpaired electrons. Ruthenium and osmium, these are important because they show the highest oxidation state of +8. Okay, they show the highest oxidation state of +8. Now we already know about Z and CDHG. These are not transition metals because they don't have any unpaired electrons. This time, no unpaired electron in D subshell. Okay, in D subshell. Actually, this was the basic introduction of the transition metals. Now we are going to move towards the physical properties. Okay, now we are going to move towards the physical properties. I'm repeating this once again. Okay, Shakti Vikraman, Feko Nikosan. Second year लाएंगे AC, तीसरा हाफ, वो नवाब था, क्रोमाटन, मंतकरे, फेरस, कौन रहेगा आयरलैंड, नहीं पढ़ पाता, क्यों आगे आओ, ZNCDHG, ZNCDHG. Okay, you can remember this whole, the important D series, 3D, 4D, and 5D series. Now, right, physical properties.
So is it important to learn 4 and 5D series?
Yeah, I mean, it will give you confidence. आपको डर नहीं लगेगा फिर किसी सवाल से. That is why it is important. Understood, Sam?
Yes, sir.
You should feel comfortable with the subject now. So just for that comfort, just imagine if you know the periodic table, why will you feel afraid from chemistry? If you know the periodic table and not as in just आपने याद कर लिया, आपको elements के नाम नहीं याद है, सारे trick याद है बस. You know the elements name, then you can also make out, and if you have some patience, you can work out their atomic number also. Okay, so there will be no hurdle, no barrier if you remember that thing. ठीक है, अगर मान लीजिए आपसे zirconium का पूछते हैं, then you can calculate and what is the atomic number for zirconium also. Okay, so in that sense, it is important to learn the periodic table. Okay, write the first one, metallic character. Right or not right, but listen. Metallic character. Metallic character is what it is defined as a tendency to lose electron, right? It is defined as a tendency to lose electron. Now, we all know the order of metallic character in the periodic table. In the periodic table, S block elements, they have the highest metallic character, followed by the D, and then followed by the P or Y. P block elements, right? S is what? As we are starting here, this is the highest metallic character, and the metallic character decreases as we go along a period like this. Okay, as we go in this period, the metallic character is going to decrease. S has the highest, then D, and then the P block elements. Right, next. How is the metallic character changing in the D block elements? In D block elements, as the number of unpaired electron increases, as the number of unpaired electron increases, strength of metallic bond increases. Okay, next thing is that we have just seen chromium, chromotan. Okay, chromium, molybdenum, and this is what? This tungsten. All of these are having how many unpaired electrons? Please tell me. These are having 6 unpaired electrons. These are having 6 unpaired electrons. That means they are going to have strong metallic bond. If they are having strong metallic bond, they also have high melting point and boiling point. Okay, इसमें भी tungsten का बहुत ज्यादा होता है, and that is why tungsten is used as what? Tell me, guys. Tungsten is used as
For bulbs.
filament of the bulb, है ना? This also have high density. If the metallic bond are stronger, then more atoms will be there in lesser volume. Okay, that is why less volume means high density. They will also have high enthalpy of atomization. That means to break the bond and bring them into atomic form, it will be difficult. They will have high enthalpy of atomization. Then we have Zn, Cg, Hg. So all of these are having how many unpaired electrons? Tell me. They are having 0 unpaired electrons, right?
Yeah.
0 unpaired electrons. And since they are having 0 unpaired electrons, they will be having very weak metallic bond. And if they are having very weak metallic bond, that these will be what? Volatile metals. And उसमें भी सबसे खराब किसका होता है? Mercury का. And mercury is present in Hg is the only metal which is liquid in room temperature. Okay, which is now the important thing is what? 6 unpaired electrons, highest, like the strongest metallic bond. 0 unpaired electrons, the weakest metallic bond. Okay, so chromo-10 and ZnCdHg, you have to remember these 3 elements whenever we are talking about the metallic character and the metallic bond strength. Right, the second part, oxidation state. The second physical property is oxidation state. Please write. D block elements. This is very important. Okay, this is very important. Mark कर लीजिएगा जब भी आप लोग लिखें. D block elements show variable oxidation state. They show variable oxidation state due to the participation of electrons from both Ns and N-1 d subshells. N-1 d subshells. Okay. For example, if I look at Fe, Fe can show Fe2 plus. In Fe2 plus, it will be having the outermost electronic configuration as 4s0 and 3d6, right? But we can also have Fe3 plus, in which it will be having 4s0 and 3d5. Also, you can see that, see, 2 electrons are removal of 2 electrons are easy, but Fe3 plus it is having 3d5, which is what? Stable. That is why it can have multiple oxidation state and variable oxidation state. This is very important due to the participation of electrons from both Ns and N-1 d subshells. Okay, this question has been asked multiple times. Why the D block elements why the D block elements can show variable oxidation state? Okay, so the simple answer is 1 marks question, participation of electron from Ns and N-1 d subshell. Okay, right, next remarks. Number 1. In 3D series, scandium and zinc do not show variable oxidation state. Okay, in general D block elements show, but in 3D series we have 2, which is not going to show what the variable oxidation state. Sc, it shows +3 only. Okay, and zinc, it shows what? It shows +2 only. Next point. In 3D series, which is going to have the highest oxidation state, Mn. Okay, in 3D series, manganese has the highest oxidation state, that is +7.
So
Okay,
there
but
are
only in the
plus
3D
8
series.
oxidation states also, right?
Which one?
Plus 8.
+8 लेकिन 45 डिग्री के elements है ना? That's the third point I'm going to write. Osmium
Okay.
and ruthenium show highest oxidation state in periodic table, that is of +8. And the fourth point. Now, this question it overlaps between the coordination compounds and the D block and F block elements, but please write here also in metal carbonyls. Such as nickel CO4, Fe, CO5, and इसमें आप लोगों को ये याद रखने की जरूरत नहीं है. The oxidation state of metal is 0. Okay, these are neutral complexes. We'll get to this point in the coordination complexes once again. Right, the fifth point. As the oxidation state of metal increases, the acidic character of oxides increases. If I look at MnO, which is having +2 oxidation state, and if I look at MnO2, which is having +4 oxidation state, then MnO2 is going to be more acidic character. Okay, it's going to have higher acidic character. Then also write Mn2O6, it is going to have +6 oxidation state. Further, you can write Mn2O7. Here it is going to have +7 oxidation state. Okay, so this is the order of acidic strength. Okay, this is about the oxidation state. The third, this was my second point. And third point, the third property, that is magnetic character. Magnetic character. Now, why do they show magnetic character? Due to the presence of what? Unpaired electron. Due to the presence of unpaired electron, D block elements show paramagnetism. Okay, and the formula for magnetic moment mu, it is equal to root under n into n+2, and n into n+2. What is this mu? It is magnetic moment. What is n? Number of unpaired electrons. Okay. So paramagnetism. Directly proportional to the magnetic moment. Magnetic moment is also directly proportional to number of unpaired electron. Number of unpaired electron. Okay. तो यहाँ पे आप लोग के पास जरूरी है क्या कीजिए? You should understand where you are having higher number of electrons, unpaired electrons, and where you are having low number of unpaired electrons. And mostly you will be given the complexes. Okay. You will be given the complexes. Please see. For example, if you have arrange the following complexes in increasing order of magnetic moment. Okay, so for example, you have MnCl whole 4, 2 negative. You have COCl4, 2 negative. You have nickel Cl4, 2 negative. Okay, so first of all, what is the atomic number for manganese, cobalt, and nickel? Tell me. For manganese, it is how much? Anyone? Shakti Vikraman.
25, sir.
Yeah, correct. Shakti Vikram 25. And cobalt is
27.
27. Nickel is
28.
28. Correct. Now, what will be the charges on these particular metals? Okay, in all Mn, cobalt, and nickel, what will be the charges? See, chlorine should have -1, right? -1. That means if you see X, all of them are having 4 chlorines and what? 2 negative charge. So the oxidation state on any of these metal will be what? X plus 4 into -1. This should be equal to -2. All of you understood this? Yes or no? Please tell me. For oxidation
Yes,
state,
sir.
right?
Yes.
So what will be the value of X? X will be equal to +2. देखिए, correct है? Yes or no? +2.
Yes, sir.
Yes. Okay. Now please see. If it is +2, that means it is going to have how many electrons? It is going to have. This one is going to have Mn, the +2 oxidation state. All of them are in +2 oxidation state. It is going to have. Tell me how much. पहले कितना था? This was 4s2 3d5. This was 4s2 3d7. This was 4s2 3d8. Correct. यहाँ पे आपके पास कितना हो गया? Tell me.
3d5, sir.
Here it will be now 3d5, and here it will be
3d7.
3d7, and here
3d8.
8.
3d8. ठीक है, अब बताइए which is going to have the highest unpaired electrons? Please remember unpaired electrons ऐसे देखते हैं ना. You are going to make 1 2 3 4 5 1 2 3 4 and 5. For d7 it is going to be 2 3 4 5 2 3 4 5 6 7. 3d8 में आपके पास क्या हो जाएगा? You have 1 2 3 4 1 2 3 4 5 6 7 8. Which is having the highest number of unpaired electrons? Tell me.
First one.
Mn. Which one? Which is having highest number of unpaired electrons?
Mn.
Mn, right? And then cobalt and then nickel. Correct. So this will be the order of magnetic moment. Okay. Got it, guys? Yes or no? Please tell me.
Yes, sir.
Okay. Now, the next important point is color. Okay. Color is also very important. First of all, they will ask you why do they show color. Third, fourth is color. Okay. Number one. All complexes having configuration D1 to D9. That means you should have at least one unpaired electron, right? There should be some unpaired electrons in the d subshell. Having D1 to D9, show color due to DD transition. Show color due to DD transition. ठीक है? There are multiple questions जहाँ पे आपसे पूछा हुआ है why do they show D? Why do they show color? Why do they show color? है ना? Why do they show color? आपसे पूछा जाएगा like Zn is not showing the salt of zinc are not colored, but for copper these are colored salt. Why? So you will write that there is no unpaired electron. Okay, there is no unpaired electron. That is why they don't show any color for zinc and cadmium and etc. Please write complexes having D0 and D10 configuration are colorless because, or rather due to absence of DD transition. Due to absence of DD transition. Now, this what is DD transition? There is a concept of DD transition when you are going to write about the complex structures. Okay, coordination complexes. Actually, whenever the d block elements they form some type of complex, the d orbitals they split up like this. Okay, into two different sets of orbital. Okay. Okay, and what is color, by the way? I hope all of you know that if you turn off the light, nothing has a color, right? Can you see any color if you turn off the light? Tell me. No, no?
No.
No, right? So light is an important thing for color. Whenever light strikes, there are some electrons here. Okay, there are some electrons here, and they jump up in the higher energy level. They jump up in the higher energy level, and then again they fall back. So as they are falling back, okay, see here. Also, one more thing. Whenever you are going to strike anything with light, these particular electrons are going to absorb. These particular electrons are going to absorb a certain frequency. Okay, they are going to absorb a certain frequency, and if they are absorbing certain frequency, they will reflect the others. ठीक है, तो मान लीजिए आपके पास विबजियोर है, right? White light has vibrior. Now, my particular metal, or the salt of my metal, it is taking all the violet, indigo, blue, yellow, orange, and green. All of these it is absorbing for the excitation of the electron. Okay, so what will be reflected back? Green will be reflected back, and then you are going to see the green color. All of you got it? Yes or no? How can we see color? From white light, certain frequencies are absorbed, certain frequencies are reflected. The remaining frequencies are reflected, and whatever the combination of those remaining frequencies is, that is the color of a particular compound, or whatever color you are seeing. Not always for DD transition. बोलिएगा सर पेंट में DD transition होता है क्या? नहीं, पेंट में DD transition नहीं होता है. That is due to extended conjugation of different electrons. Okay, so if you have dyes, in dyes you have multiple benzene rings. ठीक है? If you have multiple benzene rings, उसमें भी क्या होंगे? इलेक्ट्रॉन का ट्रांसफर होगा. These electrons which are in the conjugation, they are going to absorb some energy, and when they are going to absorb some energy, they will be reflecting back others. When they are reflecting back others, that is the color that you are going to see. What in metal salts or aqueous solutions of metal, whatever you are seeing, that is due to the DD transition. Okay, in metals. चलिए एक सवाल लिखिए. Just a second. Hmm. ठीक है, देखिए this type of question can come. Zn2 plus salts are white, that means colorless, but Cu2 plus salts are colored. Why? Your answer should be Zn2 plus has D10 configuration, hence DD transition is not possible. Then you'll also write about copper. Okay, ऐसा नहीं कि सिर्फ जिंक के बारे में लिख दिया कि क्यों नहीं होता. You will also write about copper, why these are colored, right? Copper 2 plus has what configuration? Tell me. It will be having what configuration? D. देखिए क्या होता है 4s1 D10, 2 इलेक्ट्रॉन निकाल लीजिए, D9 हो जाएगा, राइट? ऐसा नो
Yes, sir.
configuration, hence DD transition is possible, and copper 2 plus salts are colored. All of you understood this? Yes or no, please tell me. All of you understood this? Yes or no, please tell me. Okay.
Yes, sir.
Yes, sir.
No. Right, important point about KMNO4.
1 minute,
K2CR2.
can you scroll up?
Yeah. Right, some important points about KMNO4 and K2CR2 O7. Okay. These don't have unpaired electrons, but still they show color. Okay, why is that? This is not due to DD transition. There will be electronic transition. ठीक है, ऐसा नहीं कि सिर्फ मेटल वाली प्लास्टिक भी होता है, आपका कलर होता है, right? Then you have to change. These are also not metals, but they are showing color, right? So here also they are going to show color, but that is not due to DD transition. That is due to a special phenomena. This is due to a special phenomena known as charge transfer spectrum, also known as CTS. ठीक है, इसमें क्या होता है? The oxygen atom transfers its electron to Mn, converting Mn plus 7 to Mn plus 6. Okay, converting Mn plus 7 to Mn plus 6. Okay, so this transfer of electron from oxygen to Mn, that is due to the charge transfer spectrum. Okay, and this is especially known as LMCT, ligand to metal charge transfer. Oxygen is the ligand, it is transferring electron to metal charge transfer. And there is another thing which is known as MLCT. In some cases, metal it transfer electron to ligand, and that is why it's holds color. Okay, so these are two important points that you have to write about Cr2O7 and KMnO4.
Sir, what was LMCT again?
Ligand to metal charge transfer. These are, but see, these topics come overlapping between the coordination compounds and DNS block elements. Okay, so just you can write these things down in case अगर आपको सवाल पूछ लिया गया तो. Okay, right next, catalytic behavior. Okay, catalytic behavior. Most of the D block elements, most of the D block elements are used as catalyst due to the following two reasons. Number one, D elements show variable oxidation state, and hence they are converted to unstable intermediate intermediates. Why? They convert reactants to product. While they convert reactants to product. Okay. Now, when you have an intermediate which is unstable, then the activation energy it becomes lower, because if you have very stable molecules, they are going to have high activation energy. React karana bahut mushkil hoga. Okay, it will be very difficult to react to reactants which are very stable. So that is why we put D block elements, which first of all convert themselves to unstable intermediates, and then they bring up the reactants together, closer together, and then the reaction can happen, and the activation energy is lowered. Okay, so while they convert reactant to product, this reaction occurs via a different path. That means the mechanism completely changes. Different path of lower activation energy. Okay, of lower activation energy. And hence the rate of reaction increases. Second point, D elements absorb the reactant. Achha, whenever we are doing, we are using catalyst now, we always use a powdered form, and in the powdered form, they absorb the reactant. Okay, absorb the reactant and provide a suitable surface. Provide a suitable surface for the reaction. Okay, one of the very famous example that you will see is the reduction reactions. Okay, the reduction reactions you can see of CH2 double bond CH2 when we are going to convert this to alkenes, we use H2 in the presence of palladium, right? And you are going to get CS3 and CS3. Even you must have seen for aldehyde, right? In alcohol chapters, हम लोगों ने पढ़ा था catalytic hydrogenation, right? So hydrogenation and catalyst was PD, PT, or nickel. And here also what we are going to get CH2OH. One hydrogen attaches on the carbonyl of carbon and oxygen, right? Like this. Right, next, complex forming tendency. This was what, fifth, sixth point. Complex forming tendency. Now, again, there are two reasons due to which D block elements have formed has a tendency to form compound. Okay, D block elements form complex compounds due to the following. Number one, cigarette, small size and high charge density. Small size and high charge density. Small size and high charge density on metal. Just a second. On metal cations. Polarize the ligand effectively. Polarize the ligand effectively. Okay, Lubna. Small size and high charge density on metal cation polarize the ligand effectively. This is the first point. The second point. Now, all the D block elements, they will be having some vacant orbital. Okay, and that is why they can easily accept the pair of electrons that is donated by the ligand. Next point is presence of vacant orbitals. Vacant orbitals of almost similar energy to accept the pair of electrons, donated by ligand. Okay, first of all, in the formation of complex, what you should have a metal which is having a bond with ligand. Okay, this is a coordinate bond with ligand. Okay, सबसे पहले तो this ligand which is having negative charge, or it will be having high number of electrons. In order to attract this metal should be small and it should contain high charge density. And if it is containing high charge density, it is going to pull the electrons from the, it is going to pull the ligand with its electron very easily. Now, once it has pulled the ligand, the ligand is going to dump its electron. So for that, it should need vacant orbital. So you can remember it like this. First of all, they're attracting, and then they should have some room available for the orbitals, for the electrons that are coming from the ligand. They should have some vacant orbital for the incoming electrons from the ligand. So for attraction, they need small size and high charge. And for the electrons that is donated by the ligand, they need what? Some vacant orbitals. Okay. So these are the two reasons why they are going to form complexes. What is a ligand? Please write here. Okay. See, whenever we make complex compounds, there is a metal and there is something which is going to donate a pair of electron to the metal atom, and the one which is donating the electron pair, that is known as the ligand. So please, you can write it. It is an ion, or it can be a molecule also. Molecule which can donate a pair of electron to the metal and form coordinate bond in complexes. चलिए हेलो, फिर रंगे सुनो, प्लीज टेल मी. डन. यहाँ तक अब देखिए, there is an important point that is about the electrode potential. Okay, this is the 7th point, right? Many questions come from this point, that is the trend in metal plus 2 metal electrode potential. Electrode potential. Acha. See, if you remember, I have not discussed the topic of atomic sizes and ionic sizes. Okay, I think that if you read from NCERT, I will give you a highlighted NCERT. From there you can read the important points and you will understand those points. और अगर नहीं समझ में आया तो आपके respective batches में जब भी हम क्लास लेंगे तो क्लास के बाद आप हमसे देखिएगा. You always have time after the class. You can ask me after the class if you don't understand anything about the atomic sizes. There are 3 things: atomic sizes, ionic sizes, and the enthalpy of atomization. Okay. So these 3 things I have left. Whatever I have taught you now, that if you go and read the NCERT, even what NCERT I will give you the highlighted one, then you will understand it easily. Okay. अगर नहीं समझ में आया, then my class. ठीक है, आपके जब आपका क्लास होता है ना, उस टाइम आप पूछ लीजिएगा क्लास के बाद. लेकिन okay, now trends in M2 plus and M electrode potential. Now we all know that the metal have a tendency to do what? Metal have a tendency to lose electron. इसको अच्छे से समझिएगा, ठीक है? And I will be going slow in this part. आखिरी चीजें यहाँ पे आज के लिए, and then we'll be completely done with this class. ठीक है, F block elements का बचेगा, उसके लिए देखेंगे किसी दिन और एक्स्ट्रा क्लास लग जाए, या फिर you will have to do it from the NCERT that I give you, और फिर हम आधे घंटे डिस्कस कर लेंगे आप लोग के रिस्पेक्टिव बैचेस में. ओके, बट एक चीज और है, आप लोग की जो क्लासेस होती है ना बैच की, उसमें भी DNF ब्लॉक प्रॉपर टाइमिंग से कराया जाएगा. ठीक है, ये तो उन लोगों के लिए जिनका भी एग्जाम है और उसमें DNF ब्लॉक आ रहा है. ओके, सी metals in general have tendency to lose electron. Have a tendency to do what? Have a tendency to lose electron. Okay, and hence standard reduction potential of most metals is negative, because standard reduction potential, that means they are not going to reduce easily. They're going to show standard reduction potential that is going to be negative. Okay, they can oxidize easily, so उनका oxidation potential क्या होता है? Positive होता है. Hence SRP of most metal is negative. That is the standard electrode potential of most metals is negative, है ना? आप लोगों को ये भी याद होना चाहिए कि according to IUPAC conventions, SRP is what the standard electrode potential is. Standard electrode potential को SRP ही लिया जाता है. Okay, but we know that copper is going to have positive E0, right? Copper has a positive E0. That means standard reduction potential of copper is what? Positive, and hence it can liberate H2 gas when in contact with acid. ठीक है, ये भी हम लोगों ने पॉइंट पढ़ा था electrochemistry में, right? The chapa elements, they will have positive, and that is why they can liberate H2 gas when they come into contact with an acid. Okay. But why do we have this type of thing? Why do we have this point of? First of all, you have to understand the electrode potential. जो भी electrode potential होता है, that is made up of three things. First of all, we have metal. Just a second. Okay, first of all, we have what? Metal 2+. It is in aqueous state. It takes 2 electrons and it gets converted into metal solid. Okay, it gets converted into metal solid. Now there are three things that you have to take into consideration whenever we are talking about a particular change in oxidation state from aqueous state to solid state. First thing is what? जब आपके पास एक काम करते हैं, let me just reverse this one, it will be easier for you to understand. If you have metal, it is going to give you metal 2 positive plus 2 electron. Okay, first of all आपके पास क्या होना चाहिए? You are going to atomize it. Enthalpy of atomization. Okay, you are going to get metal gas. Once you get metal gas, you are going to do delta H1. First ionization enthalpy, that will be M+. Okay, then you are going to do what? This is still gas. Again another second ionization enthalpy, delta H2. Then you are going to get M. Then you are going to get M2+. This is still gas. Then you are going to hydrate it. Delta H of hydration. And then you are going to get the aqueous solution. Okay, अब देखिए, first of all, this atomization is going to take energy. Okay, this enthalpy of this delta H1 is also going to be take energy. It's also going to take energy. This delta H2 is also going to take energy. But this delta hydration, it is going to give energy. Okay, so first of all, atomization happens. And also why I'm saying that we have to first of all atomize it and convert it into gas, because if we don't convert into gas, we cannot calculate the ionization enthalpy. For ionization enthalpy of electron affinity, all of these things, we need what? Neutral, isolated, gaseous atom. Okay, we need neutral, isolated, gaseous atom, and then only we can calculate the ionization enthalpy and the other enthalpies. So for this ionization enthalpy, I need the gaseous atom. That is why first of all I atomized it. Atomized का मतलब क्या हुआ? We had a solid lump of metal, and then the solid lump of metal, I can take one atom separately. We got isolated gaseous atom. Then we did first ionization enthalpy, remove one electron. That is going to take energy. Then we removed another electron. That is going to take energy. Now, but this delta hydration is going to give energy. Now, in most of the metals, the enthalpy of hydration, compensates delta H of atomization, delta H of first ionization enthalpy, delta H of second ionization enthalpy. That means even if you are going to have, for example, in सब का sum कितना आ गया, मान लीजिए आप लोग इन सब का sum आ गया 200 joules per mole. Okay, so delta H hydration enthalpy जो most of the metals के लिए रहेगा, it will be higher than this. It will be 300 joules per mole. So you are releasing 300 joules of energy and you are giving in 200 joules of energy. So net will be what? The net is going to be 100 joules of energy will be released. And that is why most of the metals, they can easily convert themselves. They can easily convert themselves to what? To metal +2 state. But copper में ऐसा क्यों नहीं होता है? The only answer is that now again all of these things are what? Experimental. Okay, all of these things are experimental things. What happens in copper? Why is copper having positive SRP and negative SOP? Because this hydration enthalpy could not compensate for the other enthalpies. Okay, so first of all, you will write. All of you understood about the electrode potential? कैसे calculate किया जाता है? Yes or no? Please tell me.
Yes, sir.
Okay, please write here. The high energy to transform copper solid to copper 2 plus aqueous is not balanced, by what? Is not balanced by its hydration enthalpy. Okay, is not balanced by its hydration enthalpy. This is the main reason. Okay. Now we are going to see. Now, once you have understood this electrode potential, there are multiple, many questions have been asked from this part. Okay. अब हम लोग सवालों को देखेंगे and we are going to understand why is this the trend. All of you done? Yes or no? Please tell me. इसको लिख लिया आप लोगों ने? अच्छा, all of you understand why hydration is going to be stabilizing effect? Because see, metal 2 plus, okay, and then the water molecules will be like this. Okay, so this water molecule, they have lone pair electrons, right? I'm showing it by dashed lines, lone pair electrons. These lone pair electrons are what? Having high electron density. They are going to stabilize the 2 positive charge. ठीक है, attraction हुआ. Whenever you have attraction, there will be lowering of energy, and that means they are going to give out energy. Okay. So write one question. Chromium 2 plus is reducing. ठीक है, is reducing, but Mn3 plus is oxidizing. When both have not +4 D4 configuration. ठीक है, राइट आंसर. रिड्यूसिंग का मतलब क्या है? this copper full reduce नहीं हो रहा है. It is acting as a reducing agent. Okay, but you are going to get the question in the same type of language. Cr2 plus is reducing, but Mn3 plus is oxidizing. इसका मतलब क्या है? They are saying that Cr2 plus is reducing agent, Mn3 plus is oxidizing agent. Why is that? Why is that? Okay, so why Cr2 plus? If Cr2 plus is going to reduce something, then Cr2 plus reduces, rather you can read, acts as reducing agent, and its configuration changes from, it was initially D4, एक electron और दे देगा, so it will become to D3. Okay, this electron will go from D4 to D3. Okay, right, next, the D3 configuration has a stable half filled T2G configuration. ठीक है, अब T2G configuration क्या होता है? हमने बोला था आप लोग को, ऑर्बिटल्स स्प्लिट करते हैं, राइट? वी हैव 3 ऑर्बिटल्स हियर like this, and we have 2 orbitals here. This is known as the T2G orbital, this is known as the EG orbital. All of these things you will understand only when you learn complex compounds, coordination compounds, coordination complexes. ये जब पढ़िएगा, then you will understand what is this and how this splitting happens. But now you can remember that whenever you are going to have +2 state, most of the metals they are going to split in this way, T2G and EG orbitals. And as you can see, T2G has 3 orbitals, it will have 3 electrons here, and that is why it is going to be stable. Okay, you have to learn this right now. अभी आप लोग इसको प्लीज याद कर लीजिए, समझ में आएगा आप लोगों को जब when we have learned about this particular splitting. Okay, right, next. अच्छा, what is Mn doing? Mn is oxidizing agent, यानी कि Mn is going to take electron, right? So Mn3 plus is oxidizing, or rather I should say acts as oxidizing agent as its configuration changes from, अब ध्यान दीजिए यहाँ पे कैसे चेंज करेगा, यहाँ पे कॉन्फ़िगरेशन इसका changes from D4 to, it is oxidizing agent, that means what it is going to do, it is going to itself reduce, that means it is going to take electron D4 to D5, है ना, D4 to D5, and as D5 is half filled, it will have extra stability. Okay, write some other questions. Highest fluoride of Mn is MnF4, whereas highest oxide of MnO27 is, please write this question, Mn whole twice O7. Right here. Oxygen and Mn can form p pi d pi. Okay, so the pi bond is formed from the p of the oxygen atom, p orbital of oxygen atom, and the d orbital of the Mn atom, manganese atom. Okay, Please write. Oxygen can form p pi d pi bonds using p orbital of oxygen and d orbital of Mn. Okay. And it can show +7 oxidation state in Mn2O7. ठीक है. Next point. Fluorine cannot form p pi d pi bond with Mn. Hence, it shows a maximum of +4 oxidation state. Okay. Here are the 2 points. They're essentially asking when you are having fluorine, then Mn is just showing +4 oxidation state. When you are having Mn2, then it is Mn2O7, it is showing +7 oxidation state. ठीक है. तो यहाँ पे ये पूछ रहे हैं कि ऑक्सीजन के साथ ये +7 शो कर देता है और ये कंपाउंड बना देता है, राइट? बट फ्लोरीन के साथ ऐसा क्यों नहीं कर पाता है? So one thing is that if you want fluorine, then you should have what? 7 fluorine atoms. ठीक है. In 1 Mn. एक ही Mn में आपको कितना चाहिए रहेगा? 7 fluorine atoms, then only Mn can show +7 oxidation state. But the thing is, if you are going to occupy 7, if you are going to have 7 different fluorine atoms around Mn, electronegativity fluorine की बहुत ज्यादा होती है. And if you are going to attach a very electronegative, the most electronegative element, and not only 1, 7 fluorine atoms, then Mn will be what? Very, very unstable. Okay. And that is why देखिए यहाँ पे ये 7 ऑक्सीजन के साथ attached तो है, but it is having how many Mn atom? It is having 2 manganese atoms. So 2 manganese atoms are sharing 7 oxygen atoms. Okay. And oxygen has a valency of -2. That is why each Mn can show a oxidation state of +7. The only reason is that because oxygen has a valency of what? Valency is of -2. Then there is one more famous question about copper that you should write. Okay, sir. See. First is copper plus iron is not stable in aqueous solution. If something is not stable in aqueous solution, then the only reason it can have is what? The hydration enthalpy of Cu plus is very low, and hence it converts to Cu2 plus in water. ठीक है. अच्छा, ये Mn का तो हम लोगों ने देख लिया ना, because it is going to have what? The most number of unpaired electrons. Scandium at 21. Salts are what? Salts are white. यहाँ पे salt white क्यों? तो देखिए scandium आपको क्या बोला? 21. But scandium it is what? Sc3 plus. It shows only Sc3 plus, and in Sc3 plus you are going to have D0 configuration. है ना? No unpaired electrons. ठीक है. So whenever you are seeing that if something is white, something is not showing color, there is no unpaired electrons and therefore no DD transition. Okay, DD transition will not be there, and that is why they are not going to have. Now Mn plus 2 is going to have मैक्सिमम. देखिए बाइवेलेंट आयन में ऑफ द फर्स्ट ट्रांजिशन सीरीज. बाइवेलेंट मतलब क्या? Mn आप अगर कंपेयर कीजिए Fe2 plus Cr2 plus, okay, cobalt 2 plus, all of them are going to have less than 5 unpaired electrons, but Mn2 plus is going to have the maximum, that is 5 unpaired electrons. Okay, Mn2 plus bivalent में सिर्फ, please remember this in bivalent. लेकिन if you are going to look at simple neutral atoms, then it is chromium which is going to have 6 unpaired electrons. ठीक है, लेकिन क्रोमियम में भी जब आप कर लीजिएगा Cr2 plus, then it is going to have 4 unpaired electrons. Okay, bivalent molecules में आपके पास किसका होता है? Mn का होता है, the highest in the 3D series. Okay. See another question. This question of copper is very famous. ठीक है ना, देखिए यहाँ पे भी पूछा हुआ है.
Sir, can you scroll up, please?
Okay. You can see again copper unstable in aqueous solution, and again see the E naught of Mn2 plus to Mn of for manganese is much more than expected from the trend of other elements. This is because Mn2 plus में क्या स्पेशल है? Mn2 plus has D5 configuration, है ना, which is very stable. Okay, now although CO2 plus ion appears to be stable, it is easily oxidized to CO3 plus in the presence of a strong ligand. So whenever you are getting this type of question, your mind should work towards the electronic configuration. Can you please see what is the electronic configuration of CO2 plus, cobalt 2 plus and cobalt 3 plus? Calculate the electronic configuration for cobalt 2 plus and cobalt 3 plus. Sakti Vikraman, Feco. This is cobalt is what? 27, na? So in 2 plus it is going to have D7. CO3 plus it is going to have D6. Okay? So when you have got 6, you should remember T2G 6. Fully filled T2G orbital. Again splitting, okay? ध्यान रखिएगा whenever you are getting D3, D6, D5 और ये D10 तो रहता ही है, ठीक है? So these three are important. If you are getting D3 and D6, you will answer according to T2G orbital. जब आपको D5 मिलेगा, you will just answer because it is half filled. Half filled D suction. Okay. ये important है आपका because आप लोगों ने अभी coordination compounds नहीं पढ़ा है और उससे पहले you're having D block elements, right? That is why it is important. चलिए Okay. Write this down. And Lupna, you asked something now.
Yes, sir.
Okay, you are asking about the reactions.
Yes, sir.
Moving on, could you please explain this about acidification of oxidation? Oh, these are reactions itself. लुबना, आप हमें याद दिलाइए, कल आपका क्लास होता है ना? अभी मेरा नमाज का टाइम होने जा रहा है. ओके
Okay, sir.
ओके लुबना, आप हमें याद
Okay.
दिलाइएगा, कल हम आपको बता देंगे इंशाल्लाह. ठीक है?
Okay,
And
sir.
if anyone has any other doubts, now please note it down, and we can discuss it on your respective batches. Okay? चलिए. All of you done? Yes or no? Please tell me. All of you wrote this? No. Yes. Yes. No. Okay.
Yes, sir.
Thank you guys. Thank you very much. I will share the PDF. Okay.